Alright, I corrected your quizzes, and we still got a little bit of work to do. We need to do in section 5.1 there. Some good stuff. You guys are just, most of you are missing little things and kind of getting stuck or didn't have time. But luckily, section 5.3, you have to do all of that stuff plus do more after that, so we're going to get a lot more practice. So we'll think of some kind of retake for that quiz or something. We'll worry about that later. For now, we're just going to move to the next section because I feel like we're stuck in a rut with that stuff, so this will kind of break it up a little bit. Plus, this will just be more of understanding how slopes and graphs work, and the more you understand that, the easier all of it will become. So we're just going to move on to 5.2 for now. The good old mean value theorem. I'm just going to start by writing it out in words and just kind of explaining what it means. And then we'll try to draw a picture and hopefully make it make sense. Do a few example problems, and then you'll have some problems to try. I'm not going to try to do too much over the videos because this can get kind of confusing, I think, if we do too much at once. So the mean value theorem, I'm sorry, I'm going to try to stay the same volume so I don't blow you guys out with those speakers there. So if y equals f of x, so we just have a function, right? That's all that says. And if our function is both continuous and differentiable. Remember talking about that when we did limits? Continuous meaning there's no breaks. Differentiable meaning there's no corners or breaks too. But so if it's continuous on some interval from A to B, differentiable on the same interval, if those two things happen, then we can draw some conclusions. So again, where that couldn't happen, so this theorem does not work if there's like an absolute value graph, because that would be not differentiable at that point. At a corner, any breaks where it's not continuous, remember? So if you had something like that, it's not continuous right there, there's a gap, this doesn't work. That's also not differentiable right there. So anything like that. So that's all this is saying. If those things, if not, neither of those happen, so it's continuous and differentiable, then there exists the magic point. So there exists a point C, such as some point on your interval A to B, where this happens. F prime of C, oops, didn't write that very well. Should say F prime of C. Let's rewrite it. Equals, man, I'm not doing very well with my writing skills. Equals that. So what's this mean? Let you copy it. It helps if you can read this and then interpret this. So F prime of C, what's that mean? That's, think about it, that's the derivative at a point C. So the derivative of the function at that point, or the slope at that point, right? So this says like slope at point x equals C. So there exists a point where the slope at that point will be equal to, and A and B are the endpoints, right? So that's like the slope of a secant line through A and B. Or we'll just say through endpoints. X, this is just slope. F of b just means the y value when x equals b. Plug in b, you're going to get a y value. This is y minus y over x minus x, some point on the graph. Here's a picture to help this make a little more sense. It's just any random curve. I don't know. There's some endpoints. This is just the generic picture that they have in the book. So if this is A, this is B. Oops, I should line up. Yeah, there, it's crooked. So that's A and that's B. So there's my interval. This thing is continuous on that interval, and it's differentiable, so we got this part done. That's happened. So now there exists a C. So C is just some point in the middle of this thing, where the slope at that point will equal the slope of the secant line. Well, secant line is just a line through 2 points. So all this side is saying is the slope at a line drawn through the endpoints. So if this is A right here, and this is B, if I draw a line through those 2 points, the slope of that line, that's this. Oops. So the slope of that line will be equal to the slope of a tangent line at some point along this curve. So imagine if we move along this curve from left to right, it starts off kind of steep and then flattens out and then it goes way up. Well, at some point along this, see how the slopes kind of flatten out right there? Wish I had some there. At some point, that slope of that tangent line, as we move along this curve, will be the same as the slope down here. So there's that slope. At some point, those are parallel. That's what that side says. So I'll call this C. So at some point along there, the slope is the same as the slope through those 2 points. That's it. So if these two things happen, then this is guaranteed to happen. You might think, so what? But there's a lot of problems, a lot of things we can figure out by using this idea. So we'll just do a couple of examples now. I'm trying to go slow. You always say I always go too fast. Let's see. First example. We're going to use the same directions on the homework. I don't want to write them all out necessarily. It's right here. And this is the kind of problems you're going to do after this. It just says state whether or not the function satisfies the hypotheses of the mean value theorem on the given interval. So all that is the first part. Say whether it's both continuous and differentiable. So it's a yes or no question. Write yes if it is, no if it's not. Pretty sure today the ones I'm going to give you, they're all going to be continuous and differentiable. B, if it does, which they will, find the value of C that satisfies the equation. And it gives you that equation that we were just talking about. Well, so basically it's going to give us a curve, an equation, and we're going to find the point C where that slope and that slope are the same. So the first one will have y equals x squared over the interval 0 to 2. So you can probably kind of picture it graphically. You don't have to do this, but just a picture of kind of what's going on, what you're being asked. You have an interval from 0, so from here to here, here's a 1, 2. So over that interval for this function would be x squared, just be a good old parabola. Something like that, but we got endpoints. So it says along there, find the point where the tangent line to the function has the same slope as the secant line between those 2 points. So here's our endpoint, right? If you draw a line through the 2 endpoints, you get a line like this. So we're going to find the point along this curve, probably like up in here somewhere, just a guess, where those are parallel. So the way we do that is we use that equation. We use that whole f prime of c because if we know the function and we know the endpoints, we know these 2 points right here. We know the coordinates of those. And if we know the coordinates of 2 points, it's pretty easy to find the slope of a line through those 2 points. Right? The slope of the line through the 2 points is y minus rise over run, y minus y over x minus x. That's all this is saying. Y minus y over x minus x. Except we're using these. So f of b, that'd be like f of, I don't know, I usually use that one. So I'd go f of 2 minus f of 0, doesn't matter, over 2 minus 0. So all I'm doing is figuring out the slope of that pink line right now. Alright, f of 2, plug it in. Alright, because I need the y value. Plug 2 in for x, you get 4. Plug 0 in for x, you get 0. So you get 4 over 2, which is just 2. That just tells us the slope of that pink line right there. Right? The x value was 2, so the y value was 4. That's why I did 4 minus 0 and 2 minus 0. All we're doing is plugging in those points to get the slope of that pink line. That's what that side of the equation is. Remember up here? That side of the equation is just the slope of the pink line, slope through 2 points. So I know that has to equal the slope over here on this one. So I gotta find it. So where is the slope of the tangent line 2? Well, you know how to find slope, right? Slope is just the derivative of that, or f prime, right? We could have written this as f of x. So just a little side work over here. Where do I ever? I know f prime of x, the derivative of that is 2x, right? That's the equation of all the slopes. So if I plug in the x values, I get the slopes on there. So don't I just want to figure out when does that equal to? Right? When does the derivative? So f prime of c just means plug in c to your derivative. Right? C is the point in the middle somewhere. So here's my derivative. My derivative is 2x. Instead of x, I don't know, you can put x or c, it doesn't matter. But just as long as you see that if the derivative is 2x and I plug in c for x, I get 2c, same thing. Or just leave it as 2x, whatever. Because that's what you're solving for. Okay. So, whoops, didn't need to write it up there. Come down here, it looks a little simpler. 2c equals c divided by 2. Oh, c equals 1. So my drawing was a little off. That just means the x value, or that tangent line, is going to be parallel to that curve is 1. So my drawing kind of sucks. Better go back and read the question. Let's see. Find each value of c. Oh, so that's all it wanted. So I just wanted the x coordinate. So that's where it happens. Do another one. Let's just go. So you get 1/3 times 2x minus 1 to the 3rd power over the interval 1 to 2. I'm not going to try to draw this one because even the easy one, my drawing didn't work out. So I know that the derivative at some point, the slope at some point along the curve, will be equal to the slope of the endpoints, right? So I'm just trying to figure out where that happens. So I can do this side first, slope. Right, you can write f of 2 minus f of 1 over 2 minus 1 if you want, or you can just know it's change in y over change in x. right? If I subtract the x's on bottom, those are the x values. I got to get the y values. I mean, so I know some of you like to write it like this. Oh, my 2 points are 1 comma something and 2 comma something. Well, I got to find the slope between those 2 points. I'm doing the same thing. I'm just writing it different. So anyway, if we plug in 2 here, 2 times 2 is 4, minus 1 is 3, 3 to the third is 27. 27 times a third is 9. So what would I plug in there? I plugged in 2, got 9. Right? Or you could have done it here, f of b, so f of 2 is 9. Minus, plug in 1. 2 minus 1 is 1, to the third is 1, times the third is third. So I have 9 minus the third over 2 minus 1. That sucks. 27 thirds, right? That's 9 minus 1 third is 26 thirds. 2 minus 1 is 1. Probably going too fast again, but these are just fraction stuff. 26 thirds over 1. So I gotta figure out, where does the slope equal 26 thirds? Well, so remember, all we did on that side is just find the slope between those 2 points for that curve. Now we'll figure out where, or what value of x will make the slope of this 26 thirds. So do the derivative, right? Because our derivative equation tells us all the slopes. So the derivative of that, we're going to have to do chain rule. 3 times a third is 1. Inside stays. Subtract 1 from the power. And now, right, got to do the derivative. That was the derivative of the outside. Derivative of the inside would just be 2. So it's that times 2. So really we have 2 times 2x minus 1 squared. That's our derivative. So we want to figure out the value that I can plug into this guy that will make it equal 26 thirds. So we set that to 26 thirds. Like I said, you can use x or c, it doesn't matter. I'll use x on this one. It'd be crazy. As long as I know what's going on. On this side, there's my formula for my derivative. What value of x will make it equal the slope we just had over here? So I just got to solve that equation. Yay. Divide by 2, divide by 2, divide by 2, flip and multiply, right? Times by 1/2, you get 26 over 6. 26 over 6 is 13 thirds. You'll get no calculator problems like this too. So this is a no calculator. Square root it. Well, whenever you square root something, you gotta have plus or minus. 13 thirds equals 2x minus 1. And then just add 1, divide by 2. 1. Might as well just do it in one step, right? Add 1, divide by 2. So plus or minus the square root of 13 thirds plus 1 divided by 2. That would be your answer. However, so we get 2 answers. It's weird. That may be true sometimes, but we better check. Remember at the beginning, our interval, we were only cared about where between 1 and 2, right? Those were our endpoints. 1, 2, somewhere there, I don't know. So if I get an answer that's outside of those points, like out here or over here, I don't include that answer. All I care about is the values for x that makes it parallel, right? It has to be inside there. So coming down here, 13 thirds, that's what, 4? A little over 4. Square root of a little over 4 would be a little over 2. If you stopped right there, you'd probably be fine, but if that's a little over 2, so I'll say 2.1, and negative, and I add 1 to it, I'll get a negative answer. Negative 1-ish over 2. Doesn't matter. It's a negative answer divided by 2. It's negative. It's not going to be in that range, so I don't need the negative one for this problem. Just the positive one, so there would be your answer. Hardest part of this for some of you might be this part, the fraction part. That's what I fear. That's what I hate. But hopefully you understand the general idea. Take your interval, find the slope of of a line drawn through the points at that interval, right? Plug it in to get the y values for each one. Once you have that slope, which we got 26/3, come to the other side, find the derivative, and figure out where the derivative will equal that slope. And that's all you're going to do on all your problems tonight. You're going to have a function, you're going to have an interval, find the slope of the endpoints of the interval, of a line drawn through the endpoints. Find the derivative, set it equal, figure out where it equals. Done. The answer to question 1 will always be yes. I told you that tonight. State whether or not the function. Yeah, just put yes and do B and figure out where that happens. So, this quick review are just that quick review. Hopefully that works out. Oh, I lied. Dang it. That's right. The answer will not always be yes to part A. I forgot I changed the homework. From what I originally planned, they were all yes. Now one of them is no. I think. Yeah. So one of those will either, where's our notes? They'll either not be continuous or not be differentiable. So you have to look at the function first to decide and make sure. I'll tell you that. I'm not going to tell you which one though, but one of them, the answer, you're just going to write no, and then you can't do it. Because if it's not continuous or differentiable, you can't find the value of C. Right? Makes sense? Oh, that's good. Makes it more exciting, you know? You got to figure out which one it is. Should be pretty easy if you took notes and you know where it doesn't work. Okay. It's too many hints. Have fun.